Here we go. Our objective for today, I can simplify radical expressions. Read together. One, two, three. I can simplify radical expressions. So yesterday we covered functions. Today we're going to expressions. So what are expressions? Let's find out. Radical expressions are an expression that contains a radical sign. Radical expressions are an expression that contains radical signs. Examples. Square root of 25, 8 times square root of x, square root of x squared plus 6x plus 9, square root of x over 4 minus 6. Those are all examples of radical expressions because it says an expression that contains radical sign. Non-examples, let's see. We got, move this out of the way. We got square root of x equals y equals x plus square root of 16, and negative 3 plus x squared. Think about it. Why are those non-examples? And I'll give you some time to copy that. So once again, we found out that these are equations. This one is an expression, but it doesn't have a radical sign. So therefore, copy this. Expressions that contain a square root. Simple as that. Expressions, and they need to contain a square root. Steps. It's only 4 steps, but the last step has other steps, so copy this. Steps. It says, simplify radical expressions. Step 1, simplify. Step 2, factor completely. Step 3, identify the square root. Step 4, write the radical expression in simplest form. The radicand has no perfect square factors other than 1, fractions, and no square roots in the denominator. Now, for those of us that forgot the terminology for radical expressions, here it goes again. I'm going to write over here on the side. This symbol is called the radical. An expression that's inside, such as x plus 1, that is what we call the radicand. And the index is the number outside of the radical. This is the index. Remember that? Bless you. And whenever they give us a square root, the number outside, an invisible number, we know it's a, but what number is it? If it's invisible, it's a 2. Whenever it doesn't have an index outside, we automatically know it's a 2. Okay, I'm going to erase it. But whenever you don't see an index outside, what number is it? 2. Copy that, please. Okay, so once again, key steps. If you skip any of these steps, you're going to end up with a wrong answer. So make sure the very first thing you do, you simplify. What do we do first? From there, once we simplify, or if the radical expression is already simplified, then the next step is to factor completely. From there, you identify the square roots, but remember, at the end, we need to write the radical expression in simplest form, which means we need to simplify again. What does that mean? That the radicand, which means the expression inside, has no perfect square factors other than 1. It's not a fraction, and there are no square roots in the denominator. Okay? So, with that said, look at this. Now, in the past, I remember when we got to the quadratic functions and quadratic equations and such, I said, okay, guys, what cancels a squared? A square root. Remember that? This cancels this. That's why we end up with this right here. However, from this point forward, even though we already know this, I want you to write the answer not just as x. I want you to write it as absolute value of x. Why is that? Because what value can I substitute in here? Check this out. Let me give you an example. For example, let's say I substitute the number 3. What is 3 squared? 9. What is square root of 9? 3. It gives me the same number, right? However, if I substitute negative 3, what is square root of let's see, negative 3 squared is what? 9. We still end up with a positive 3. Does everybody see that? We substitute a positive number, we ended up with a positive number at the end. We substitute a negative number, we ended up with a positive number at the end. What do we know in math that we can substitute values inside of that it comes out always as a positive? What have we done in the past that if we substitute any numbers in it, it comes out as a positive? An absolute value. That's why at the end we need to write x with an absolute value. So that is only going to apply when we have a variable inside of the radical. That will only apply when we have a variable inside of the radical. Tell you never what I just said. All right, copy this down, please. Example 1A, B, and C. Copy those, please. Let's do this one together. Step 1. What is it? Simplify. So look at this fraction, 2/50ths. What does it become if we simplify it? 1 over 25. You bring the square root down. Copy that. Oh, my bad. Sorry. 1 over 25, square root of that. Copy that, please. Okay, from here, if we look up, at this point, since it's the square root of the entire fraction, I'm going to split it up. This becomes square root of 1 over square root of 25. Are we there? So at that point, so what is square root of 1? 1. What is square root of 25? 5, and we're done. Yep. Is it in simplest form? Look at it. Is it in simplest form? Yes. Okay. So now, check this out. This is a property that only applies when you're dividing radicals. This is called radical, quotient property of radicals. These are radicals because it's a radical expression, right? Quotient because what is the operation when it's a fraction? Division. So whenever we have a division, we can actually split it up into two radicals because it's still a division. Are we there? So with that said, let's go to the next one. What is our first step again? Simplify. Now some of you might be tempted of doing this. Everybody look up. You see the square root, you see the square. Some of you might be tempted of doing this. That is incorrect. Why? Because there's addition in between. You're skipping order of operations. So the first thing that we need to do is simplify. What is 8 squared? 64. What is 15 squared? 225. I said 8 squared is 8 times 8, which is 64. What is 15 squared? 15 times 15, which is 225. So therefore, let's simplify this. 225 plus 64, that's 289. 289. So think about it. What is the square root of 289? One number times itself gives us 289. So this is the way my brain works. And I'm thinking, what number ends with a, well, what number times itself gives me a number with that's a 9, or it ends in 9? 3 times 3, or 7 times 7 is 49. So my possibilities here are 13 times 13, or 17 times 17. However, look at this. Where did we get the 25 from? 15. So if this one is 15 times 15, could it be 13 times 13? No, because we added more. So then the answer is 17. Everybody see that? Okay, let's go to the last one. Let's see. Step 1, simplify. Can we simplify any more in here? We can't combine like terms. There's no common, GCF or anything. Step 2, factor completely. What do we use? Power Rangers. We got 9. That's what? Oh, this is the product. Sorry. This is the product, and negative 6 goes down here. It's our sum. So what factors of 9 add up to negative 6? Negative 3 and negative 3. So how can we write it in here? X minus 3. Do I need to write it again, or can I simplify it? What can I write? Squared. So I bring down the radical. What do you notice? Now you can cancel out. This cancels this, and we're left with x minus 3. Wait. We're done. But x minus 3 what? Absolute value. Remember, if we have a radical with a variable, at the end we need to write it with absolute value. Are we there so far? Okay, let's do a couple more. Copy these down, please. Example 1DE. Example 1D and E. Example 1D is square root of 256 over 4. And square root of, and example E is square root of 40 plus 9. Do those two by yourself. Follow your process. Remember, simplify, then factor completely if possible, and then simplify again. Go. Here goes the process. Can we simplify this first? Yes. So now some of you reduced this fraction by 2. And you got square root of, let's see, this is 128 over 2. You reduce it again by 2, and that becomes 64 over 1. Which is what? 64, right? Square root of 64 is 8. You can do that, or you could have divided 256 by 4, which would have been 64. And then square root of 64 is 8. Either way is fine. What's that? That also works. But remember, what is the first step? Simplify. So get used to simplifying before you do the square roots. Okay? Let's go to E. This becomes square root of 40 plus 9, which is 49. Therefore, square root of 49 is 7. Okay? Hands if you got those two by yourself. Okay, good. Let's move on. Copy this next one. Example 1F and 1G. F is square root of 5 squared plus 12 squared. And G is square root of, parentheses, 3 minus X squared. Copy those and see if you can do those by yourself. You got about a minute. Go. Okay, let's see. I'm going to get somebody to help me out with this one. How about Ash? Go. So for this one, she got 13, but I need you to help me with the steps. What did you do? 5 times 5, which is 25 plus 144, 169, and that's how you get 13. Hands if you got that. Okay, the next one, go ahead, Sabrina. Cross out the square root with the squared, and we end up with what? 3 minus X. Hands if you got that. Okay, oh, she's not done, my bad. Absolute value. Hands if you're done with that. Yes, that is correct. Okay, let's move on. Copy these next ones, please. Okay, before you copy the next one, pay attention, please. Focus, please. Eyes up here, you don't need to copy that. Earlier, I said there was a property that we used for division, and it was like this. Everybody look up, please. I gave you something that looked like this. Square root of 2 divided by 50. And I said simplify. That was the first step. That became 1 over 25. From there, this became square root of 1, square root of 25. And the square root of 1 is 1. Square root of 25 is 5. And I said, when we split them up from 1 to 2, this is what we call the quotient property of radicals, right? Well, guess what? If there's a quotient radical property, which means a division property, there has to be one for what? Multiplication, for product. What does that mean? that we can have something like this, and then we split them up into two. You guys notice that? Is able to see that? And that makes it a little bit easier to simplify. Notice, did it make it easier here to simplify? Yes. So let's do that with multiplication. Copy this down, please. Copy it, and then I'll go ahead and do this one first, and then I'll give you some practice one. Example 2a says, simplify. All variables represent non-negative numbers. Square root of 24. Copy that, and then I'll go over it. Okay, here we go. Pens down, eyes up here. Focus, please. So, step 1 is to simplify. Can we simplify any more? Step 2 is factor completely. Now, if I was to factor here, pens down, eyes up here. Pay attention, please, or else you're going to miss it. If I was to factor here, I would do a factor tree and start factoring and doing all that. However, from this point forward, I want you to think about it like this. What two factors give me a product of 24? Watch, and this is what I do. I start listing them first. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, out of those factors, or pairs of factors, I'm going to choose the pair of factors that has a perfect squared number. But I'm going to choose the one that has the biggest perfect squared number. Now you're saying, what are you talking about, Mr. Q? Let's see. Look at this one. Is 1 a perfect squared number? Yes, because you can take the square root of 1. Or 1 comes from 1 times 1. How about 4? Yes, because 4 is square root of 4 is 2. It comes 2 times 2. So these two have a perfect squared number. But which is the biggest one? The 4. Perfect squared number. The 4. Therefore, this becomes square root of 4 times 6. Now, if I use the property tells me that I can split this up into 2. This becomes square root of 4 times square root of 6. Are we there so far? At that point, what is the square root of 4? 2. And this one. Can we find two more factors of 6 where one of them is a perfect square? Let's see. 1 times 6, it's 1, but other than 1, 2 times 3, no. So this one we're done. So this one is 6. So we're left with 2 square root 6. Copy that, please. Yes? What's that? No, on this one we don't graph. Now, the reason I listed all the pairs of factors so that you can see which ones they were. But you don't need to list them if you don't have to. You can just think about what would be the factors where one of them is a perfect square, and then simplify from there. There we go. I'm going to give you another one. See if you can do this next one by yourself. Square root of 45. Simplify that, please. Copy it. And go. So, by thinking about it, let's see, 1 times 45, nah, 1 is 1. 2 times, no. 3 times 15, yeah, but 3 is not a perfect square, 15 is not a perfect square. 4, no. 5 times 9, yes, 5 times 9, 9 is a perfect square, so therefore this becomes square root of 5 times 9, which becomes square root of 5 times square root of 9. So what is square root of 9? 3. Can we find the square root of 5? No. So that stays the same, and we're done. Hands if you got that. Okay, let's do another one. Careful with this one. Square root of 32. Go. Okay, here we go. Let me move this up. So, let's see. Factors of 32. We got 1 times 32. I'm going to write them out over here on the side so you can see. 1 times 32, 2 times 16, 3 times nothing, 4 times 8, and then they repeat, right? So, which ones have a perfect squared number? 1, 16, and 4. All three of them do. But I said go with the one that has the biggest one. Therefore, you should have written square root of 2 times 16. Because 16 is the biggest perfect square. This becomes square root of 2, square root of 16. What is square root of 16? 4, and we're left with square root of 2. Now, some of you did this. Right away you saw the 4, and you did this. Square root of 4 times 8. Is that correct? And then all of a sudden you did this. Square root of 4, square root of 8. And you said square root of 4 is 2, and we're left with square root of 8. However, can't we factor 8 out where one of them, of the factors of 8, is a perfect square? Let's see. 1 times 8, 2 times 4 is 4, a perfect square. Yeah, so check this out. If you were to do this, you can actually go further. 2 times 4. This becomes 2, square root 2, square root 4. 2, what is square root of 4? 2, and then we bring down the square root of 2. What is 2 times 2? 4 square root of 2. Don't we end up with the same thing? Yeah, but it's more work. Yes. No, we're done. So, once again, you have to go with the biggest perfect squared number of the pair of factors. So, copy this next one down. We got numbers down. Let's go with variables. Yay! Copy this. Example 2b, square root of x cubed y squared. So let's do this one together. From here we do the product. Huh? Y to the fourth. X cubed y to the fourth. This becomes square root of x cubed square root of y to the fourth. Now, at this point, I can simplify this second one. Why? Check this out. Pens down, eyes up here. If I have x to the 10th, this becomes x to the 5th because there's an invisible 2 here, and all I have to do is divide the exponents. The next one, x to the 16th. This becomes x to the 8th. Why? Because I divide by 2. So what did we agree? That these need to be even numbers. So is this an even number? Yes. So what is 4 divided by 2? Y squared. Are we there so far? So we're done with this one. But this one doesn't have an even number exponent. But we can break this one down like this. X squared times x. This becomes x squared, x squared, and this is x. Can we divide this one? Yes, this becomes x to the first. And what do we have left? Square root of x. Copy that, please. I know. It's fairly simple if we really look at it, and we're going to do one more so you guys can see it. So underneath that, I want you to copy this one. Square root of a to the 5th, b to the 12th. Okay, so let's do this one together. This becomes square root of a to the 5th, square root of b to the 12th. So which one of these two can we simplify at this point? Why the 12th? Because it's an even number exponent. So what is 12 divided by 2? 6. So this is b to the 6th. We're done with this one. Now I'm going to focus on this one. This becomes a to the 4th times a. What do you notice I did over here on this one? Everybody look up. This one. I split this 3 up into 2. 2 and 1. I split this 5 up into 2. 4 and 1. Everybody see that? So therefore, at this point, this becomes square root of a to the 4th, square root of a to the 1st. So which one of these can we simplify? So what does this become? A squared, and we bring down the square root of a, and we're done. Homework is found on page 708, numbers 1 through 23, and I need all of these. So There's tutoring today. Pharmacy and tutoring. Have a good one. Enjoy your homework. See you guys tomorrow.